Hello, everyone. We'll get started here in a couple minutes, but just a few administrative items before we get started. Due to the large number of attendees, we will be muting everyone's microphone during the session. You can type questions in the questions pane located in the control panel. I will answer some questions at the end of the session, but also feel free to send us comments about the webinar or additional questions to webinars@csiamerica.com. Also, all webinars will be recorded and posted on our website. Okay, so let's get started. In this example, I'll be applying wind loads in two different ways. First, based upon exposure from extents of diaphragms, and then I'll be manually applying wind pressure coefficients to the walls themselves. So first, we'll talk about defining diaphragms, assigning them to the structure. Then we'll spend some time defining wind load patterns and going through each of the individual items associated with that. We'll run an analysis. We'll view the loads on the structure. We'll take a look at some response plots, view a summary report, and then we'll draw some auto cladding and then apply wind pressure coefficients to each one of those walls. Okay. So under the Define menu, we'll go to Diaphragms. And we have two different options here, rigid and semi-rigid. So for a rigid diaphragm, you have infinite in-plane stiffness and it doesn't exhibit any membrane deformation. And for semi-rigid, it simulates actual in-plane stiffness properties and behavior. So for the first example, let's use a rigid diaphragm. You'll notice that once I apply a semi-rigid diaphragm to the structure as well, the loads get distributed differently. And we'll take a look at that load distribution after analysis. So once this rigid and semi-rigid diaphragm have been defined, we need to assign them to the structure. To do so, we can go to the Select menu, and we're going to select all the floor elements. So if we go to Select Object Type, and I'm going to select Floors. Click the Select button, and you'll notice here in the bottom left-hand portion of the screen, 19 shells have been selected. It's kind of a bookkeeping system, so it shows you exactly where the rigid diaphragms are going to be assigned to these 19 floor objects. So then we can go to Assign, Shell, Diaphragms. And we'll select rigid diaphragm and apply it to the structure. So you'll see here on the right side of the screen, this kind of spider web image represents the diaphragm which has been assigned to the floor element. And if I step down to each one of these floors, you can see that a rigid diaphragm has been assigned to each one of them. That's the base, and now we're going back up to the top. So you can see all of the diaphragms have been assigned correctly. Okay, so next, let's go and define a wind load pattern. Now, diaphragms are necessary for load applications to the wind loads themselves. So if we go to Define Load Patterns, we can define a wind load. It is important to select the correct type when it comes to assigning a wind load, because ETABS will automatically generate load combinations for you and will associate the correct scale factor based upon the type of load which you have defined. So under auto lateral load, you can see these are all the different codes which have been included in ETABS. Many international codes, as you can see, For today's presentation, we'll be discussing the ASCE 716 code. Okay, for this first example, we'll be discussing exposure from extents of diaphragms, and we'll talk about the exposure from shell objects in the next example. So first, we need to define the wind pressure coefficients, windward and leeward. Windward coefficients are used in calculating wind pressures on the windward side of the diaphragm, the side exposed to the wind, and leeward side, just the opposite. So we'll leave all the default coefficients 0.8 for windward and 0.4 for leeward in this example. Wind direction and exposure width. Let's take a look at this table. Okay, so we stepped through each one of the floors, showing you the rigid diaphragm had been assigned to each one of them. So ETABS understands and calculates the width and depth for each one of those diaphragms. Here are the X and Y coordinates for the center of mass for each one of the floors. Now you can see the exposure set width is auto-calculated based upon the location of the diaphragms in ETABS that we have assigned. But you can also define an exposure set that can be user-defined. So you can click on each one of these cells here and make changes to them manually if you like as well. And there's a direction angle up here. So 0 degrees will be wind load applied in the X direction. We can also define another wind load pattern with different degrees, perhaps 90 degrees, which would be wind loads applied in the Y direction. So for this example, we'll keep the degrees at 0, wind load application in the X direction. Okay, next, let's take a look at the case ASCE 716. Now, the program combines loads for each one of the 4 wind load patterns. So if I select Create All Sets, ETABS will automatically generate all 12 load patterns for you based upon the different angles and E1, E2 ratios. Let's take a look at this in depth. So these are the different load patterns which will be automatically defined. PX and PY would be the resultant wind force in both the X and Y direction. And the E1 and E2 eccentricities for loads in the direction applied of the wind is input by the user. So you can see here, lateral force as well as torsional moment will be automatically applied to the structure. Here's another image I'd like to talk about. You can see that case 1 and case 2, full design wind pressure acting on the projected area perpendicular to each principal axis of the structure will be considered. Case 1 and 2 are shown here graphically. 3 and 4 will be defined just like case 1 and 2, but considered to act simultaneously at 75% of the specified value. So in ETABS, you have the opportunity to select each one of these load patterns and have them defined, or you could just select one and ETABS you could define them manually as well. So you have a few different options to work with when defining the wind exposure parameters. Okay, also wind coefficients can be defined, wind speed, exposure type, gust factor, all of these can be manually updated here in this form. Now for exposure height, top and bottom story height specify the elevation range over which the structure is exposed to wind. So I have it predefined where the penthouse roof, the top story, and the base, the bottom story, the full structure will be exposed to wind. Let's take a look at another graphic. Okay, see figure 3.1 here. Now this, I'm just pulling some of these figures from our lateral loads manual. Gives a good representation of how loads are distributed to the diaphragm using the extents of diaphragm method. So here we see a building elevation on the left-hand side, exposure width for the second level diaphragm, as well as the roof level diaphragm. This is a good representation of our model, which does have a penthouse level. You can see the wind loading at the roof level will be applied using half the height of the roof. And then the wind loading at the second level will be similar, except half the height of the roof as well as the second story will be considered in load application. Okay. We've taken some time to define a wind load pattern. For this rigid diaphragm, why don't we run the analysis and take a look at some output and spend some time on that. Okay, once this is running, you'll notice, as I'd mentioned before, the load distribution of how the loads are applied to the structure, if you're using a semi-rigid or rigid diaphragm, are different. So we can take a look at how the loads are displayed in both of those scenarios. Okay, the analysis has been run. Now let's take a look at loads on the structure. To do that, we can click on Display, Load Assignments, Joint Loads. The wind load pattern, which we have defined, load type can be forces, and we'll have the program show the loading values. Let's take a look at this in plan view. So click on Plan. Let's start off with the penthouse roof level. And you can see that because I was using a rigid diaphragm, all of the lateral loads are being applied to the center of mass. So if I step down to each one of these floors, this is the wind load that is being calculated and applied to each one of the floors. So let's take a look at a few different ways to take a look at output here in ETABS. We looked at load assignments. Let's take a look at some story response plots. So you'll see here, the display colors are blue represents global X, red is global Y. Let's take, right now we're looking at maximum story displacement. There are a few different options here. Lateral loads to diaphragms. You can see here, you get a graphical representation of the lateral loads which are applied to each one of the floors. And you can define multiple wind load patterns, different story ranges. All of these options are available to the user. Diaphragm drifts, maximum story displacement, as well as story shears. Now, all of these graphs can be, of course, viewed on the screen, but they can also be exported and printed in a nice report format as well. And I'll show you that next. Okay, you'll notice on the Model Explorer here on the left-hand side of the screen, there's a Reports tab. So if I right-click on this project report and we click on Modify Report, you can take a look at all the options available in generating a report. It's a very user-friendly report in the sense of the user has complete control as to what they wish to have included in this report. So for the sake of this presentation, we're looking at auto wind loads and auto wind calculations have been included in this report. So if I click create report, this just takes a moment to run. Okay, it's just in the bottom left-hand portion of the screen, you can see that it's just finishing the analysis results. And now the report viewer pops up. I'll make this a little bigger, easier for everybody to see. You'll notice the table of contents located on the left-hand side, including all the basic definitions, story data, point coordinates, line connectivity. But what we're interested in here today are the auto wind loads. So if we scroll down to load patterns, it gives you all the information for load pattern definitions, the code you used, the diaphragm locations, as well as the definitions. We'll take a look at auto wind calculation. So this is a very useful tool. I'll make this a little bigger. So it's not such a black box. You can see the exact variables that were used to calculate the wind loads here in ETABS. Exposure from the diaphragms, exposure category used, all the different coefficients, all the different factors, velocity, pressure are calculated. And if we go to the next page, here's that image that we'd shown using the story response plots. Lateral loads to stories, excuse me, have been printed here for each one of the different levels. A lateral load application has been applied to each one of the stories in a graphical format, and also you can see the information here in a tabular format. Now for this specific example, all the loads were applied in the X direction. Okay, let's take a step back here. Everything I've shown you so far is related to a rigid diaphragm. I've created a similar model, except in this model, all of the diaphragms were assigned as semi-rigid. And I wanted to spend some time showing you the differences in load application between the two types of diaphragms. So let's quickly run this model here. So after this model runs, we're going to take a look at some auto cladding, apply some cladding to the structure and apply wind pressure coefficients to that. Okay, this model analysis is run. Let's take a look at display, load assigns again, joint, and that same wind load pattern, except this time, remember, a semi-rigid diaphragm has been applied. Again, we'll take a look at this in plan view. So you'll notice a difference here. For the semi-rigid diaphragm, to avoid stress concentration, semi-rigid diaphragm applies loads to 10 different points along the perimeter of the building. So if I step down here, instead of having the point load applied at the center of mass, you'll notice that loads are applied along the perimeter of the structure. And that is the main difference between semi-rigid and rigid diaphragm load application. Okay, and then just lastly, we'll take a look at display story response plots. And we'll make sure we select a wind load case, and we'll also look at the application of loads to the diaphragm, this time semi-rigid. Okay. Let's look at this model in 3D view. I'm going to unlock the model now. Okay, now under the draw menu, let's talk about adding some cladding to the structure and then applying wind pressure coefficients to them. So under the draw auto cladding, cladding consists of shell objects with a none section property that are added to the outermost perimeter of the structure. Cladding properties have no weight or structural properties. Its intent is to facilitate application of wind loads to the structure. So there are a few different options available to you. I'm going to go through each one of these. First of all, just based upon the locations of the floor elements, cladding can be generated automatically along the perimeter of the structure. So we'll click the use floors, and if we click OK here, one thing, I need to turn off the extruded shape to have the cladding show. Okay, so now you have some gray shell area objects that have been applied to the structure. Now, if I rotate this around, actually a better way to view this is to look at the elevation C, which would be along this face. Okay, I'll turn off the extruded shape here. Okay, look, so it drew some cladding on the structure, but you'll notice that cladding was not added to this floor here, the second floor. And that is due to the fact that there are area objects located on the perimeter on the floor below, so it didn't recognize the location. So that's fine. We can make changes to it very easily. So what we can do here is we'll go to the second level and apply cladding now using the beam elements. So if we click on plan view, and I think it's the third story, let's take a look. And what we could do is, I'm going to take the time to select all of the perimeter beams and then use those beams as the basis of generating the cladding. So I'll just zoom in here a little bit. And I'm going to select all the beams on the extents of the structure here on the perimeter. This just takes a moment. I'll just zoom in here. We'll select some more beams. And I'm going to turn off the extruded shape here so it's a little easier to view the beam selection. Couple more. Okay, now we'll go back to the draw auto cladding tool, and this time we'll select beams. So now you see the cladding has now been added to that story, which was initially missing. So this is very common, this is a model that has some unique geometry. I'll rotate this around a little bit. You can see there's some curved shell elements on the right hand side. And I'll turn on back the extruded shape. Oh, maybe not. Anyway, the point of this is to show you that there are some curved elements located on the far right-hand side of the corner of the structure. Let's turn that extruded shape off. There we go. So you see cladding has been added to the entire structure. So now, if we go back to that elevation C, we can use these area objects, these cladding area elements, to apply wind pressure coefficients. So I'll go to elevation C, which is this face right here. So what I can do is I can just select these area objects. And again, if you look at if I just go to assign, excuse me, shell loads, and then wind pressure coefficients. So I'll apply this wind pressure coefficients to this wind pattern name. 0.8 in the windward, I'll click apply. I can also add 0.4 to the leeward. Oh, but you'll notice here, after I clicked apply to the windward load, the loads were automatically applied here on the left-hand side of the screen. So if I rotate this a little bit and take a look, you can see there's the load application. Oops. 0.8 in the windward direction, excuse me, and I could do also the same for in the leeward direction. 0.4, click apply. Once you apply the load, you need to select the area objects again. So I can click previous select here using the tool in the left-hand corner of the screen. And then for leeward, I can click 0.4. That's a better angle there. You can kind of see the load application. Okay. I think this is a good time to perhaps field some questions. I'm going to open up the control panel here and take a look at some questions that have been asked. Okay. Just give me 1 second here as I open up some of these questions. Okay, my colleague is going to join us here. Okay, one of the questions here. Okay, can ETABS assign a different parapet height for each of the primary building directions? If not, is there a recommended workaround?
You can assign different parapet heights for the different directions if you make 2 separate window patterns for them.
Okay.
There's one on rigid, semi-rigid diaphragm above that.
Okay, let's see here. Okay, 1 second. We'll get some more questions here.
Yeah.
Okay. Oh, when defining a semi-rigid diaphragm, is a program able to calculate the in-plane stiffness characteristics of the diaphragm based on materials, or do those values need to be calculated outside and entered by the user?
Yeah, the program is able to calculate the in-plane stiffness of the semi-rigid diaphragm based on the thicknesses and the materials that are that comprise those floors. Oh, you already showed.
Yeah. Okay. There we go. Does the depth parameter in the wind load pattern definition correspond to the story height, or is it the width?
That is the planned dimension in the other direction. It is not the story height. The gust factors can be calculated automatically for some of the codes where the natural frequency of the building is accounted for, but that is only applicable for some of the codes right now that we have more details on.
All right. So when you modify exposure height, What mean roof height is used to base the wind loads off of? I guess that's
if you the top of the exposure height should really always be the roof. If you use something lower, that actually means that you're going to apply some additional loads yourself to the roof.
okay. Oh, here we go. When do you need to assign diaphragms with different names, perhaps D1 and D2?
That is if you really want, there are two portions of the building that are connected by some flexible members. You can have 2 or 3 or more diaphragms assigned to each floor, and each one of them should be given different names, so that, and then you can have some flexible members connecting them. So it's like, or you could even have 2 towers that go down, and you may want to keep those separated. There's one way up there, at the very beginning. What is a spider web?
What does spider web center correspond?
The center of that spider web is the centroid of that particular floor. And one of the things to be noted is that even though in the rigid diaphragm, the load is applied at the center of mass, we translate the actual load application point to the center of mass. So the load is applied with the particular force as well as a moment, a torsional moment to the center of the mass, so that the actual application point is not changed.
At the end, let's see, could you please talk about a little about the difference between load patterns and load cases?
Yeah, the load patterns are a simple way for you to keep your bookkeeping for the different loads that you've applied. The load cases are actually what is actually analyzed, and you can have load cases as a combination of multiple load patterns, so that you can have them summed up with different scale factors. Yeah, we don't have to answer that. What about this one? No. Can you repeat how we just talk about it?
Okay, it says they're asking about repeating. How do you assign cladding? So under
through different methods.
Oh, right. So under the draw menu, auto draw cladding. These are the different methods I used. First was using the area objects, floors, excuse me. And then when there was an issue with that 1 second story, I went back and assigned cladding using the beam elements that were selected. Why do we apply wind load in windward and leeward directions?
Yeah, the main reason for doing wind load in windward and leeward direction, you're talking about the coefficients that are applied to the shells. And if you apply the windward, if you say it is windward, then the program will base the loading on the height at that particular location. If you say leeward, in most codes, the leeward load is constant based on the highest elevation in the structure.
Here's a good one. Can we apply user-defined wind loads without a diaphragm?
You can apply any load to any joint or to any shell. So yeah, you don't have to have a diaphragm to be able to do that. But then that's basically all under user control. Slow that one, don't do it. No. Yeah, you should be applying only one.
Yeah, that's right. It says you've applied a leeward and windward to the same load pattern. Isn't it cladding is acting as windward is the opposite of leeward? That's correct. I just kind of was, for the purpose of the presentation, I should have applied them in different load patterns. That is correct. Do we have to apply wind loads on both diaphragms and cladding at the same time? No, you don't have to do that. Shouldn't be doing that. That's correct.
Yeah, you will have to apply it separately also. I mean, you can do it through the diaphragm. You can apply it.
Right. So the question is how to apply roof wind load if the roof is sloped.
You have to do it on the area.
So you'd have to apply wind pressure coefficients on the area object itself.
For some course you do.
Okay, so does ETABS consider the gust factor based on the building's natural frequency, or must the user calculate that separately?
Yeah, we do have the capability of the program calculating the gust factor, but that is limited to some of the codes, and those are defined in the user's manual for which code we actually calculate ourselves. And the program calculates it. It is done, yes.
Does a program calculate the center of rigidity for both rigid and semi-rigid diaphragms, and does it show it?
Yeah, it is in one of the tables.
Yes, and one of the display output tables can show you that. Shall we define different load combinations when using a code other than ASCE 710, positive and negative values for wind load?
When the program automatically calculates the design loading combinations, we do have positive and negative values used in separate load combinations. If the user is defining it yourselves, they should have loading combinations, one for positive direction and one for the negative direction. Yeah, cladding is only for that, yeah.
Is there any point to using the auto draw cladding function if you're applying user wind loads? Auto cladding is only to apply wind loading via the cladding elements, correct?
Yeah, yeah, you're fine. Yes.
That is correct. Can we see the graphical center of rigidity of each floor?
That is not currently possible, but we will consider that.
Yeah, currently that's not possible. We'll consider that in the future.
Oh, yeah.
Do we define one diaphragm to all levels, knowing that the slab thickness, hence the stiffness, will be different from one level to another?
Yeah, you can assign the same diaphragm name to it. The program will actually have different diaphragms inside for calculation of the stiffnesses.
Okay, a few more here. If we consider only one load pattern for wind and select a case as create all sets, does it automatically consider both in X and Y directions, or do we need to create separate load patterns by changing the direction angle?
If you assign a load pattern to say create all sets, the program will create actually 12 load sets for the ASCE code, and they will be included in the same load case, which will have 12 different answers, each one of them considered as a separate case. And when they are used for design purposes, each one of them is used in the loading combination for design.
I can just show that under the define load cases, you'll notice that.
You will only have one.
Yeah.
But if you show the
Oh,
results,
sorry.
the results.
Yeah. But also in the load patterns, you can see if I'd selected all, create all sets, then it would all be automatically generated.
Once you design, yeah, once you analyze it.
Yeah, right. Okay.
Answer all of them.
Yeah.
We cannot take all of them, so we'll answer them all.
Yeah, that sounds good. Okay. Due to the large volume of questions, we will answer all of the questions that were not discussed here today and do a response to the group. Wanted to thank you all for attending today, and please check our website for further webinars that are being introduced. The next one is on Thursday, discussing the auto-lateral load application of seismic loads. And again, thank you very much for attending. This webinar is being recorded and will be posted on our website here shortly. Thank you very much.